Guys, it's CMAC here. Today we're going to talk about object-oriented programming. 4 major principles in object-oriented programming. I'm going to take a different approach. This is going to be very short, hands-on video to get you started with OOP, right? I'm going to assume you just got hired by one of the major companies in space exploration project, right? And your first act is to actually build a spacecraft simulator, right? We're going to build this in an object-oriented manner. I'm going to walk you through abstraction, encapsulation, inheritance, and polymorphism. So without further ado, let's get started. All right, guys, we're going to start building a new project by just creating a new simple Java project. I'm using Eclipse. You can use, any other IDE. Doesn't matter as long as you can run Java code. All right, so my project called Spacecraft Simulator. Right, this is my project. So I'm going to create a package here, basically to logically separate my codes, and I'm going to name it just com.cmac dot spacecraft. Perfect. All right, and I'm going to create a class in here called spacecraft. All right, let's talk about our first concept, which is encapsulation. Encapsulation, any object in real life, it has properties, right? Humans, they have height, weight, age, things like that, right? These are properties. These are things that we label, we connect them to the object. Now, every single class, every single entity in real world can perform different actions. For example, humans can walk, can run, can sit, can eat, can sleep, right? These are behaviors. So behaviors basically perform some actions based on the properties and data that we put in the class. So encapsulation basically says if you put data or basically properties here and combine it with all the methods, all the behaviors in one place, it's called encapsulation. So when we put data, for example, we say spacecraft has, for example, fuel type, right? Spacecraft has, let's say, launch date, right? These are all properties. Spacecraft has, for example, model, right? These are the things that basically these are properties of a simple spacecraft, right? These are properties. And then we're going to build some methods, right? And then we say, okay, we can actually start the engine, right? So we can start that spacecraft, and I'm going to basically use camel case everywhere. We can basically, set launch date, and these are methods that we can apply to any spacecraft, right? You can extend it as much as you want. We're going to keep it very simple here to just show you how object-oriented programming can be used, right? So when we put data and behaviors in one place, we call it encapsulation. All right, very easy. So the second concept that we're going to use in this class, so when we name a class, we talked about the class, it's a place that we design our ideas, right? We say spacecraft, it's got, these features and these methods, right? But in real life, spacecrafts are very complex objects, right? But how do we simplify this thing? So we use a concept called abstraction. So basically abstraction means we're going to simplify things. We're going to hide a lot of complexities in, to get started, right? We don't have to share all the complexity of an engine in a spacecraft to the entire world, right? People just want to be able to start the engine, in the control tower, or, whoever the pilot is, they just want to be able to push the button and get the engine going, right? They don't need to know any detail about the spacecraft engine and all the complexities and details, right? This is called abstraction, right? When we hide complexities, right? Complexity, it means we are using abstraction. All right, so let's get started. I'm going to actually start very simple with a very simple properties. I'm going to say the spacecraft has model, right? We all agree. The spacecraft has fuel type, right? A spacecraft has launch date. So I'm not going to use a data type date here because I'm going to make things very, very simple, right? I'll let you, deal with that later. So let's look at this class. So first of all, I'm making everything private. It means from outside world, I don't want to share any of my secrets, any of my internal secrets, how I work, how I, how my internal program operates, right? So we keep all these properties simple, right? Imagine you have an engine and you let the pilot in airplane to set the fuel level, whatever, that basically goes to the engine. So what if that pilot, injects more fuel than the normal, standard? What if, so the engine will get into fire, right? So we always want to hide complexity from the outside world. That's what's called abstraction, and that's what we're doing here. All right. So now we have spacecraft with 3 basic things, right? We're going to keep it very, very simple. So the next thing we need to do, we need to go to source here, and we basically create some setters and getters, right? And the reason we do that, because we need some public methods, right? Think about it. We have basically used private identifier here, right? Access modifier here to hide all the complexity from the outside world. Now we need to provide some public interfaces so people or other classes can talk to our classes, right? But if we want to set, for example, fuel type, right, we can put our business logic here to prevent any violation in terms of injecting fuel to our engine, right? We can put the business logic here to protect any failure, right? Because we are not exposing our variable directly to the outside world. So nobody has access to this private method. I hope this makes sense. Let me know if not. Leave a comment and I'll answer all your questions. All right. So this spacecraft, we have properties and we have methods. All right. We just implemented encapsulation in object-oriented programming. All right. So one more thing we need to build here, and that is called a constructor, right? A constructor is the first method that will be called as soon as we create a real object from this blueprint. Remember, we talked about building a blueprint. So classes are blueprints. It does not exist until we create a new object. Remember BMW example that I gave you. So once we create a new object from this blueprint, then we have an object that basically inherits all these methods and all these properties. All right, so constructor is basically the first class that it gets called after creating a new object. All right, let's keep going. String fuel type, and then what else we have? String launch date. All right, so we say if you want to create a new object from this class, this guy will be called, right? And then you need to basically set all the incoming data and set it to the object, set the object properties. All right, the next one is, of course, launch date. It's going to be launch date. And the last one is going to be, for example, model. I mean, if I want to keep it a little bit neat here, I can actually do this. All right, what we're saying here, we're saying whatever comes in, model, fuel type, launch date, whatever comes in goes to the same variable, but take a look at this keyword. This keyword means the existing object, whatever you're working with, right? If you're creating a new object, these properties, they belong to the object, and these are the incoming variables, parameters, right? Whatever you want to name it. All right, so let's get going. We have a very simplified version of a spacecraft right now. We're building a spacecraft simulator, right? We have properties and we have behaviors. We combine them, it's called encapsulation. We are hiding a lot of complexities from outside world, which is called abstraction. We're making things very simple. We might have 20,000, 10,000, 5,000, hundreds of properties for all of our objects or classes across our big Java project, but we don't want to share all the complexity with the others. So we hide them, and by abstraction we can basically accomplish that. All right, so let's get moving. Let's go and create another class. Now, imagine your design team in the spacecraft, space exploration company. They'll tell you, okay, we're going to have two different models of this specific spacecraft simulator that you're building. One of them is going to be V9000, and one of them it's going to be X5000, right? All right, so we create a class, perfect, and we say V9000. It is going to be a spacecraft, right? It's from the same family. So take a look. Public class V9000 extends spacecraft. So basically, we're telling, okay, use the same base because this is a spacecraft. It's going to have all the same things that this guy has. But we're going to extend it. We're going to attach a few more properties to this guy and make it more customized to V9000, all right? All right, so it says you have some unimplemented methods. You have to implement those methods. Perfect, and this is actually what we want. We want to be able to pass few things, right? We say V9000, the name is V9000. The fuel type is, for example, liquid oxygen, and launch date is whatever date in the future, right? So now what we did here, if you're basically using inheritance in order to eliminate duplicate codes. Why is that? All right, if you go back, every single spacecraft, right, needs a model and basically needs some getters and setters to set the model and get the model, right? And if you have 20 different type of spacecrafts, so we have to implement the same code over and over in 20 different subclasses, right? We don't want to do that. So inheritance basically helped us to inherit all those methods, which is set model, get model, fuel, whatever, set fuel, get fuel, inherit those in V9000, so they become available in V9000, so we don't have to retype them again. And it's going to help us reduce the amount of code that we have to build and the amount of complexity in our code. So this is called inheritance. All right, but here's the thing. I want to say my V9000, guys, it's going to have a property called color, right? I'm going to set V9000's color, and I'm going to set it specifically for spacecraft, for this spacecraft. And I'm going to create a Boolean. Booleans are basically true and false variables, right? You guys know it. And Autopilot. Let's say I want to create Autopilot, right? And the private, this is going to be basically private string color, and this is going to be private Boolean Autopilot. Again, I'm hiding complexity from outside world, but how do I give access to people to work with these objects? Basically, it's by adding setters and getters, right? You go and create some setters and getters for this specific type of spacecraft. But here's the thing, if you notice, how do I set color and Autopilot then? I don't have anything because my spacecraft class does not know anything about color and Autopilot properties. All right, this is where it becomes interesting. So as I said, we are extending spacecraft class so we can add more features. When BMW created, remember in the first example when I gave you, in BMW X3, you might have specific features for that specific type of BMW. It makes sense in real life world, so you can relate to it, right? We're going to use the same concept here, guys. So I'm going to say string color, it's only specific to this V9000, and of course I'm going to have Boolean Autopilot. All right. So if you look, spacecraft knows about the first three, and V9000, which is a specific feature, which is a specific brand or model of the spacecraft, has two extra features. So we can add or add basically new features to our extended class. So I'm going to say, okay, my superclass, who's the superclass? Of course, is the spacecraft, right? Because it's the parent class. I'm going to pass these three guys to my superclass, which is spacecraft, because he knows how to deal with this tree. Take a look, right? So basically, I'm calling it constructor class in the parent class, right? By using a super keyword. So I say super, my parent class, please take these three values and deal with it. I don't want to deal with them, right? So, but I still need to deal with two other properties here, which is one of them is color, one of them is autopilot. And as you can see, I'm exposing setters and getters. They're public, they're not private, right? They're exposed to entire world, but the properties are hidden from outside world. All right, so in the constructor, I'm setting model, field type, and launch date. I'm passing them to the superclass because he knows how to deal with those, but I still need to deal with two things, which is a color object of this spacecraft. So again, color, this color comes in and it sets the color of this V9000 spacecraft. Very simple. The second one, autopilot, it's same thing, autopilot. All right. So basically, when we create new object, the constructor class, which is the first class, it will get called, right, for V9000, and it will receive basically three properties, right? Those three properties will be passed to the parent class because he knows how to deal with those two properties. And then we have two extra properties here that our superclass doesn't know anything about them. So we're going to customize it, custom build only in this class V9000, right? So the spacecraft is a parent class and V9000 is a child class, is a subclass, right? We inherited a bunch of things from this spacecraft class. All right, very simple class, right? We're going to repeat the same thing for another model. I'm just going to copy a bunch of things from this class and I'm going to build it. The next one, it's going to be X5000, right? X5000, it's going to have exactly the same feature, right? It's going to be basically pretty much the same. Public X5000. This is constructor. Constructor is the first method that it will get called when we create a new object. It does not have a return type. All right, so remember that. And it's public for sure. All right, so let's create again these two guys. All right, perfect. Now we do have, why it's giving me error, because it doesn't know anything about our superclass. So we need to extend, we need to tell Java, this is basically, again, it's a spacecraft, but it's just a specific model of the spacecraft. All right, so I think we're in a good shape here, right? So we have two main classes called X5000 and V5000. They are flight simulator, right? And so the last one, X5000, we are going to add one more specific feature. Think about it. We are customizing our classes. We're customizing our objects. X5000 is a very modern, basically spacecraft. Let's say we want to have project manager's name, project manager, and we're going to have string project manager. We're going to put the project manager in this class. So this class has one more feature, right, which is basically setting the project manager for this project. And the way we're going to do it, we're going to again go back to source, getters and setters. We're going to build some setters and getters for this object. All right, so our X5000, it's got one more, it's the same thing like V7, V9000, but it's got one more feature, one more property. It's called project manager. All right, now we are basically ready to go ahead and start testing our project and see how our simulator works. All right, the last step here, guys, it's I'm gonna call it app, and we know if we want to tell Java this is the beginning of our project, we create something called main method, right? Public static void main string R's. We can pass bunch of arguments to it. All right, I'm going to create one spacecraft 9000. I'm going to name this V spacecraft, right? This is a V model, and I'll tell Java this is a new V9000. All right, it's a new V9000. Tell me about the model. I'm going to say yes, this is called V9000. This is the model, right? And it's got -B. This is for example, second version. Fuel type, it's liquid oxygen. Launch date is 4/16/2020. All right, and the color is blue. I'm setting all the properties, right? And the last one is true because this guy has autopilot feature. All right, so we are just creating a simple object from that class. So I'm going to create a second one. This one I'm going to call it X5000, and this is called X Spacecraft, and it's going to be X from class X5000. All right, and this is going to be again X5000, and this is called CA model, liquid oxygen. This one will be launched in 10/16. And the color of this one is white, and unfortunately it does not have that feature. So take a look. We're building two spacecrafts with different features. We're customizing features. One of them, it's got autopilot, one of them doesn't have autopilot, right? Well, if you recall the X5000, it's got one more feature, which is project manager. Why don't we just add this in Constructor, right? And pass it as a property to the constructor. That's one way, right? I'm not going to do that because I'm going to show you a different way of doing that. But let's now work with those basically objects that we just created. All right, so I'm going to use system out the println, right? I'm going to say this is my V9000 spacecraft, right? Very simple. And I'm going to have another one that has X5000, right? X5000. All right, so we're going to need a bunch of system out here. I'm going to build those. So, all right, let's copy this guy. We're going to need it. All right, so what we're going to do, we're going to actually use our object, which is called V spacecraft. We're going to start with V spacecraft. V spacecraft dot. As soon as you hit dot, you will see a bunch of methods that we can apply to a spacecraft type V9000. And one of them is basically to start. All right, where is it? Let's go down. I want to just show it to you guys first. Let's go back, sorry. All right, I'm gonna add a method here to start the engine, right? Public, it's gonna be void, it's not gonna return anything, and I'm gonna name it start engine. And what's gonna do, it's gonna just print, it says started, engine started, right? So when I call this spacecraft, V spacecraft, and now start engine becomes available here, right? And it's just gonna print spacecraft started for me. Let's give it a try. Let's run this program. All right, as you can see, it says V9000 spacecraft engine started. All right, but what if our V9000 spacecraft has different type of engine and starting mode? Like let's say it's got turbo or double turbo, X mode, whatever, normal mode. So how do we customize those features? It's very simple. So we have a base definition of starting engine. If you don't, redefine those in your specific types, which are X5000 and V9000, the base class knows about how to starting the engine, right? I hope this makes sense. Now, let me explain this further so you'll definitely get it more clearly. All right, now we come here. In V9000, I say, you know what? I know that spacecraft class has a class and knows how to start an engine, but I'm V9000. I have a different behavior when you start my engine. Okay, I say, what is it? So it says, can you give me that start engine? I want to work with it. I say, yes, sure. So if you take a look, it says I'm going to overwrite whatever my parent says. Who's the parent? Is the spacecraft. And it says start the engine normally, right? It says I'm going to overwrite and I'm going to basically apply my own rules. I'm going to tell you how to start my V9000 engine. All right. And as you can see, Java by default injects super.start engine. Basically, it's calling the start engine method in spacecraft class. I don't want that. I want to say, okay, I want to say here, all right, we're going to say V9000 started in turbo mode. All right, V9000 says, okay, I have a different turbo mode for to start my engine, and I'm not going to use the base start engine method that you provided in the parent class. I'm going to use my own. I'm going to override this, right? So when we call start engine, Java will look for the specific start engine method in V9000. If there is one and it's overridden, it's going to use this guy. So we're going to have a bunch of complex method here, or basically business logic here, right, that we're ignoring right now. Later, our design team, our engineering team, they're going to tell us, they're going to help us how to complete this complex, business model. But for now, in order to keep this sample very simple, we're just going to print things on the console here so we understand how things work. But in real life, in the future, once you created your MVP or model, your base project or your minimum viable project, and show it to everyone who's like, this looks good, so you can go ahead and add more codes to your methods and make it more complex and better. All right, so V9000, we learned it's got a different way of starting its own engine. Let's go back. So if you recall, when I ran the program, it used basically the start engine code from the parent class. But this time, if we run it, it says V9000 started in turbo mode. And the reason started with turbo mode because V9000 overrided the default behavior that inherited from Spacecraft. And it says, no, I have a different way of turning the engine on. So this is very, very now clear. Now we see what's going on here. All right, let's move on. vSpacecraft dot. Let's see what else we have. All right, I'm going to say, okay, can you tell me what the fuel type is for the specific engine? And Java says, sure, I have a method that it's exposed. It is public, right? And it is going to, and we're going to actually use that because this method only returns the fuel type, right? Now we need to just print it on the page. So it says, go ahead and get the fuel type from V9000. And if you go back to V9000, you look for get fuel method. There's no get fuel method in V9000. Again, we know this class is extending Spacecraft. Spacecraft already knows about fuel, right? So all the complexity, it's inherited to the subclass, right? By extending Spacecraft class. So if you look now, this guy knows how to set the fuel and how to get the fuel, right? And V9000 doesn't need to duplicate that code. That's the power of inheritance. That's the power of object-oriented programming, right? So Spacecraft, since it's coming from Spacecraft supermodel, right, superclass, V9000 knows already what the fuel type is. So now if you run the program, it says, I don't have any method in me, but my parent that I inherited all those properties knows how to get and set the fuel type. As you can see, we set the V9000 Spacecraft fuel type to liquid oxygen, and now we're tell us what the fuel type is. It says it's liquid oxygen. All right, let's say what else we have here, and I'm going to create another method here, Spacecraft object here, and I say, okay, can you tell me what the color is? I'm like, okay, and I run it. It says, yes, the color is blue, and we see it. Yes, when we created this new object, we basically call the constructor V9000, and we pass the color blue as a color, and now it's being set as a base color for this type of spacecraft, for this type of space machine. All right, so let's move on, and now we're going to use the second one. Bear with me, we're very close to the end of this tutorial. This is a very in-depth, hands-on, simple version of object-oriented programming, so you guys can learn how things work. All right, so here I'm going to now use Spacecraft, and Spacecraft, it's got the same thing. I say, okay, get color, and if you look here, let's actually maybe add a few lines here. I'm going to use few \n here, and let's run this guy. All right, so it says Spacecraft, as you see here, we passed white as a color. So Java knows this object X5000, it's basically the color is set to white. So when we get the color that we already set when we started this. So X space program, I'm going to set start engine. Actually, X5000 is a basic model. It does not have the turbo model. So when we call this, it's going to actually look for start engine method in X5000. It says, do you have any X start engine method, customized one? It says, no, I don't have it. It says, okay, then go ahead and get it from the superclass, which is Spacecraft. It goes back to Spacecraft. It says, do you have any? It says, yeah, I do. It's a very simplified generic version of starting the engine method. It says, okay, go ahead and use it. As you can see, in the last one, we had a turbo model, but this one starts just normally with any, without any customized model. All right. What else do we have? I'm going to have spacecraft dot. Let's say I want to get the launch date. I want to see what day we're going to launch this. It says, okay, 10/16, and we passed 10/16. So I basically inherited all the methods and properties from the main class, from the parent class, which was Spacecraft, into V9000 and X5000. There's one thing before we move on to the last one, which is polymorphism, I want to tell you about. And that is one feature that we added extra to our X5000 spacecraft model. All right, and that was basically project manager. And when you look at this, we never set project manager when we construct a new object. And I said, okay, constructor is the same name as the class. It's public, and it does not have return type, right? That's called constructor. It's the first class that will get called when you create a new object from this blueprint. So how come this one doesn't have project manager? We say, okay, when you construct object, we still don't know who's going to be the project manager. So, right, it's going to be basically empty string. It's going to be null. There's no value. But if one day you assign a project manager to this project X5000, you have a public method because the variable it says is private. Nobody can access this, but there is a public setter, right? In here, if you look, it says set project manager. You can pass the set project manager. It comes in here, and then basically it will set the project manager for this type of project. I say, oh, that's cool. I actually, now that we're a few months in the spacecraft project, now what we can say X spacecraft dot set project manager, and I'm going to name this CMAC, right? Or I'm going to name this John Smith. All right, perfect. And then a little bit further, I can actually go ahead and now say X spacecraft dot get project manager. Or if I run this project now, and you see now I have John Smith attached to X5000. However, if you go back to V spacecraft, and if you put set, there's no project manager, right? This class does not have this feature. This type of spacecraft cannot, have a project manager assigned to it, because by design, basically, this is how we designed it. And the goal here was to show you we can create custom things from our superclass, and they can have different behaviors. They can overwrite things, and basically they can have their own customized way of working. All right, up to here, you learned about what the encapsulation is, basically putting all the methods and data in one place in a class. It's called encapsulation. We hide complexity from outside world by basically using private access modifier. So we hide everything from outside, but we'll give people public interfaces so they can plug things to our class, and they can pass it so we can process them internally. Then we created two classes of X5000 and V9000 from the spacecraft. We extended that class, and we added some more properties and features to that specific model. We overrided starting the engine method, in V9000, and we told Java, okay, we have a very custom way of starting an engine in V9000. But X5000 does not have that start engine, customized version. So it's going to go ahead and use the spacecraft. So we learned that how basically inheritance can help us reduce code complexity and eliminate a lot of duplicate code. And at the end, we learn how to create a new object, how to send values to our constructors method, right? And then constructor methods basically pass those to the parent class, because the parent class knows how to deal with those properties. The last concept now we're going to talk about is actually polymorphism, which is actually very, very cool concept. All right. So you said basically from this type, I want to create a new object that is called V9000. It's called V Spacecraft. So in Java, you can basically, instead of referring to a specific version or basically specific blueprint, you can still point or basically create an object from spacecraft, because V9000 at the end of the day is still the spacecraft, right? It knows, and the reason is because we are extending V9000 from spacecraft. So V9000, when we create a new object called V9000, we can actually refer to the parent class, which is spacecraft. Same thing for X5000, right? Ignore the errors for now. I'm going to tell you why, and we're going to fix those errors. But the idea here is to tell you that V9000 spacecraft, X5000 spacecraft, at the end of the day, they are spacecrafts, right? Instead of explaining their specific version of V9000 and X5000, we converted this to what? To parent class, which is spacecraft. Now, if we move on to our code and we say, okay, V9000, V spacecraft dot get color. Why get color right now? It's giving us error. It says, I don't know anything about getting or setting a color. I don't know anything about color. And why is that happening? And if you look, we told Java, go ahead and create a new spacecraft from spacecraft. Because again, V9000 is a spacecraft. And if we go up one level, spacecraft, we created an object from spacecraft. And spacecraft said, I don't know anything about color, right? So polymorphism basically gives us flexibility to have different behaviors for a specific object, for different objects, right? So now we understand why getColor method doesn't exist, because we are creating a new version from spacecraft, and spacecraft doesn't know anything about getColor. The reason getColor was working because up here we had V9000, and V9000 knew about color, knew how to deal with that. But since we don't have it here, we're going to get some errors, right? Let's remove this code. And same thing here, getColor, getProjectManager. These are custom build properties and methods for only those type of classes, right? But in order to understand how polymorphism works, we're going to actually use only our start engine method, so you guys simply can see the difference here. All right, so here's the English version of this writing. It says, from a spacecraft, whatever spacecraft is, right, which we have up here, it has model, fuel type, launch date. It doesn't know anything about project manager, doesn't know anything about color, doesn't know anything about autopilot. It says, from a spacecraft, right, I want to create a new version 9000, which we are calling 9000 constructor, right, and understands all the parameters that we are about to pass to it. It says, okay, they are both called spacecraft. They're coming from that family type, and they both have start engine method. And why? Because our spacecraft, it does have a start engine model, right? If I run this program now, if you look, it says, okay, let me put one space here so you guys can see it much better. 2 new line here. And I have a habit of cleaning my code like that, and you run it again. All right, this is very interesting. So up to here, we have start engine. They're both calling start engine, and they are both coming from the same class. But V9000 says I have a turbo mode. I start the engine in turbo mode. X5000 says I started the engine in normal mode. And the reason that's happening, you are calling a start engine method in a spacecraft, but Java pays attention to the specific type. It says, okay, although you're saying you're getting an instance from Spacecraft, right? And a Spacecraft is supposed to just print engine started, right? Nothing customized here. But I'm going to go look for V9000 and X5000, 5000. I'm going to look for start engine method to see if I can find it. And it says, you know what? V9000, it's got its own version of starting an engine, right? And I'm going to use that instead of using a generic one. But X5000, it's got nothing about starting. It doesn't have any method that points or overrides the start engine method. So I'm just going to go ahead and use the base model. So now polymorphism, start engine basically is behaving differently than starting engine. We're calling the same method on the same type spacecraft, but they have different behaviors, right? So this is polymorphism. You are calling the same method, but they are acting differently. This is polymorphism. This is the power of object-oriented programming. All right, guys, I think we're at the end of our example, spacecraft simulator. You're successfully implemented spacecraft simulator in Java, using Java. Along the way, you'll learn what the encapsulation is, which was combining it, data and method in one place, put it in a class, and then you learn how to extend classes and basically leverage inheritance in order to reduce the amount of code that you're about to duplicate. You don't have to duplicate things when you're using inheritance. You learned about abstraction, how to hide complexity from the outside world and make things simple, and only expose things that it's necessary for the outside world in order to talk to our service. And then at the end, you learn how polymorphism works in Java by calling the same method but getting a different behavior. As you can see, V9000, it's returning a different behavior than X5000. And I'll hope you like this explanation. Please review this a few times to completely understand object-oriented core concepts. I hope you liked it. This was a simplified version of a spacecraft, of course, right? The goal was basically to show you how object-oriented programming can be used in real-life examples to build more awesome, flexible projects, software projects. Subscribe to my channel, leave any comments below, and until next time, bye.